Hi students, today we are going to observe the applications of derivatives topic which is related to the JEE main and Disha publications questions. Okay, one by one we will do. That is in Disha publications, it is going to be our the chapter number, let us observe the chapter number, that is sixth chapter, applications of derivatives. Okay, yes. Look at the first question. The question goes like this. So the first question is here. A water, a water tank has the shape of a right circular cone with axis vertical and vertical downwards. Its semicircular angle is tan inverse 3 by 4. Water is poured in it at a constant rate of 6 cubic meter per hour. The rate in square meter per hour at which the wet curved surface area of the tank is increasing when the depth of the water in the tank is 4 meters is. Okay. This is the question. First, let us understand the question and then what is given in the question. Let us observe that. Yes, come on. You see here. The question here, the question says that the water has the shape of right circular cone. Okay. So it is going to be right circular cone and with axis vertical and vertex is downwards. You know, this is going to be our vertex, right? This is going to be our vertex. It is going to be downwards. Okay. And this is our cone. Okay. Yes. Now you see here, what are the things are given? Semi-vertical angle is given. Let us observe what are the things which are present in the cone. So we know that the cone, whenever you talk about the cone from center, the base is no doubt a circle, right? So that this is going to be radius, right? Because this is a circle in the base of a cone is in circular in shape. And when you draw the, so this point can be called as vertex or apex, right? From apex or vertex to the center of the circle is going to be our height. Okay, we know this. Yes, very good. And you see here, this is going to be the slant height. Okay, this h is going to be our slant height. And when you see the semi-vertical angle here, the vertical angle here, this is going to be theta. Let us take this as theta. Okay, yes. So now we write what are given first. So here it is given that a cone with a semi-vertical, semi-vertical angle is equal to tan inverse 3 by 4. Okay, this is given. Let us take tan inverse 3 by 4. It is the ratio given. So let me equate this to theta. This is the total angle, right? So if you take, then what will be the tan theta? Can I take tan theta as 3 by 4? Okay. Yes, very good. Tan theta is equal to 3 by 4. With respect to this figure, can I write tan theta? This is going to be 90 degrees, right? So this is our theta. With respect to theta, can I write tan theta? Yes. What is tan theta? Tan theta is going to be opposite side by, okay, opposite side by adjacent side, or you can say base by perpendicular. Okay. Can I go with or by h here? So base is here or and h is perpendicular. Okay. Yes. So tan theta is equal to 3 by 4 and it is equal to or by h we got. And look at the, come on, go further in the question. Water is poured in it at a constant rate of 6 cubic meter per hour. So this is very important, you see. What is that? 6 cubic meter per hour. Okay, meter per hour. Let me take. So cubic meter, what it represents? For which it is unit? Yes, very good. Volume, right? Per hour. So time. With respect to time, you are saying. Whenever you say with respect to time, this is no doubt. Yes, dV by dt. Because with respect to time, it is going to change, right? So dV by dt is given as 6. Right, very good. And then next, you observe the next part of the sentence. The rate in square meter per hour at which the wet curved surface area of the tank is increasing. So the rate at which the wet curved surface area, the wet curved surface area of the tank. So the wet curved surface area of the tank, right? They are asking this total thing, right? This part. I will shade it. Yeah. Okay. So wet curved surface area they are asking of the tank is increasing when the depth of water is in the tank is 4 meters. So when the depth of water in the tank is 4 meters, then what will be the increase in, it is not direct curved surface area. They are asking increasing, so at what rate it is going to increase. So what is the meaning? At what rate with respect to time it is going to change its area, right? Curved surface area. But at a particular condition that when H is 4, okay? When the H, because no doubt H is also changing, right? Whenever you are pouring water, with respect to time, the height of the water goes on changing, okay? Or the depth of the water goes on changing, no doubt. And then the curved surface area, how it is increasing with respect to time at a condition that when the depth of the water is changed to say 4 meters, that is given. Okay, right, very good. So what we have to find actually, so the rate of at what rate the curved surface area is increasing. So can I call that as, because either increase or decrease means that is rate of change. Yes, no doubt ds by dt I have to find. Very good. And but what is the condition? The depth of water in the tank is 4 meters. That is, the depth of the water is in 4 meters. So at height, so the depth of the water, that means whenever the height is going to be 4 meters, at that time, what will be the curved surface area we want? Okay, understood? So this we have to find. Very good. Yes, come on. Let us observe dv by dt is equal to 6. You know that. Now this is no doubt a cone, right? So cone, what is the, because here you got an idea, you got a clue that volume, right? So can we write the volume? Yes, very good. What is volume of cone? Volume of cone is equal to 1/3 pi r square h. We know this, correct? Yes. So volume of cone is V. Very good. And then you know here dV by dt is given as 6. Okay. So can I substitute the values here? Okay. Because I have two variables. So if I convert it into one variable, then it is very easy for me to find any kind of I can solve the question easily. So that what I'm doing is I want to convert I want to convert one variable in terms of the other. Okay. Let me convert that now. Come on, you see here. So pi r square h. So what is h here? So can I take h as 3 by 4? Yes, tan theta is equal to, we know, tan theta is equal to r by h, right? So can I take r and h tan theta? R is equal to h tan theta. Yes? Okay. Then I am substituting here. Let us substitute that. So r is equal to, instead of r, I have to substitute. R is equal to h tan theta, I am substituting. So h square tan square theta into h. Okay. So it becomes 1/3 pi h cube tan square theta. Okay. Understood? Right. What you do now? So this is going to be volume we got. Okay. Volume is equal to 1/3 pi h cube tan square theta. Very good. Now you see here pi h cube. What about tan theta here? We got tan theta as 3 by 4, right? So can I substitute that? Tan theta is equal to 3 by 4. Okay. So I can substitute that. Then what I am getting? 1/3 pi h cube into tan square theta is going to be, so can I write it as 9 by 16 here? Okay. 9 by 16 tan square theta. Then what do I get? So 3 one time, 3 times. Okay. So what do we got? 3 pi h cube by 16, right? 3 pi h cube upon 16 we got. Okay. Very good. So this is volume, right? Now what I'm doing is, because we know dv by dt is equal to 6. Yes. Okay. So can I differentiate this one? So differentiate with respect to t. Okay. So when I differentiate this with respect to t, I am getting dv by dt is equal to, so 1/3 pi. Okay. So this one I will take directly. Why? Because I simplified this, no? So I'll go this. I'll go with this 3 pi. Okay. 3 pi h cube by 16. So 3 pi by 16. So I'm keeping the constant outside. And then can I differentiate this h cube, because h is variable. These are constants. Okay. Yes. 3 h cube. How do you differentiate? 3 times h square into dh by dt. Okay. Right. Very good. Now you see 3h square into dh by dt. What is dv by dt? dv by dt is going to be 6, right? Yes, very good. So if 6 is equal to, what I do? 3 pi by 16 into 3h square, right? Into 3h square into 3h square into dh by dt. Okay, dh by dt. But what they asked here in the question, they are asking that the value of the depth of the water in the tank is 4 meters. So dh by dt at h is equal to 4 we want, right? So if you know dh by dt at h is equal to 4, then you can easily find ds by dt at h is equal to 4, correct? So for that reason, I am going to write dh by dt, okay, dh by dt at h is equal to 4. So can I go with, so 3 one time, 3 two times I can write, okay? And then 2 is equal to, what I get? 2 is equal to 5 by 16 into 3 into, can I go, because h is 4, okay? Yes, 4 square into dh by dt. What I'm doing, dh by dt, I'm finding, okay? This dh by dt I'm finding at h is equal to 4, right? Yes, come on, what do we get? Let us observe. So dh by dt at h is equal to 4. So 2 is equal to, so I am sending all the things to this side. 16 pi. So let me cancel here. 16 cancel. So 3 pi is left. Okay. So can I go with 2 by 3 pi directly? Yes. 2 by 3 pi is equal to, what do we get? 2 by 3 pi is equal to dh by dt at h is equal to 4. Yes. Okay. dh by dt at h is equal to 2 by 3 pi. Okay. So at h is equal to 4 means the depth of the water is increased to, the depth of the water, when the depth of the water 4 meters, okay, the height, the rate of change of height with respect to, the rate of change means the change in height with respect to time is going to be this much, 2 by 3 pi. Can I write the units? What are the units for this? So it is going to be meter per hour, right? Meter per hour. You got this, right? So what do we want actually? ds by dt at h is equal to 4. Yes. Okay. Come on, you copy this. Okay. Are you solving? Yes. Very good. Let us observe now. I am erasing this part and I will go with curved surface area, right? Because they asked, what they asked in the question, that is the rate in square meter, the rate in square meter per hour at which the wet curved surface area of the tank is increasing, at which the wet curved surface area of the tank is increasing. So the wet curved surface area or the curved surface area of the, what is this, cone, right? So the curved surface area of the cone is nothing but s, right? Generally we denote with s. So what is the curved surface area? This is going to be pi r and l, right? So pi r l. Yes. Okay, very good. And you see, and now you can observe here pi r l you got. So I don't know l, right? Because you know r and h. Okay. So can we write in L in terms of R and H? Yes, very good. Come on, can you calculate L? So L is equal to what? Because by Pythagoras theorem, we can apply that R square plus H square. Okay, very good. And then here you see, because I am writing this in terms of H, okay, or in terms of H. So what is R here? R is going to be, you see, 3 by 4 is equal to R by H, right? 3 by 4 is equal to R by H. 3 by 4 is equal to R by H, okay? Then R is equal to 3H by 4. Can I go like that? 3H by 4 whole square plus H square, okay? Instead of 4, I substituted like this. So it is going to be 9H square by 16 plus H square. Okay? Right. So 9H square plus 16H square divided by 16. That is going to be, so it is going to be under root. I forgot that. Okay? So for all you will get root. Okay? Root you keep in brackets. Square root in brackets. Right. Okay. Then what do we get finally? Under root. So this is going to be 25H square by 16. Okay? Yes. 25H square by 16. So which is 5H by R. 4, right? 16, root 16 is 4. So we got 5H by 4. So can I substitute here? Yes. Now 5 into, what is R? R is equal to, R is also 5 into R into L. Let me write 5 into R into L is how much? We got 5H by 4. Okay? 5H by 4. Now what is R? R is going to be 3H by 5 into R is how much? R is 3H by 4. 4R is equal to 3H. H is equal to 4R by, sorry, H now we have to find. Yeah. So R is equal to, instead of R I am expressing in terms of H. Okay. R is equal to 3H by 4. Okay. 3H by 4 into 5H by 4. Okay. You got like this. So pi into 15H square by 16. This is our yes. Correct. 15H square by 16. Yes. Now I want to calculate what do we want actually? We want ds by dt at h is equal to 4. Yes, can I differentiate this with respect to time? Okay. Differentiate with respect to time, with respect to t. Okay. So can I write it as ds by dt is equal to pi into, okay, 15 by 16 into, what is h square? H square is, can I write it as 2h into dh by dt? Yes, this is very important. Generally, students will do mistake here. What they do, h square means 2h they are going to write. Okay, generally we will our relative is x, right? So y is equal to 2x. What do you write? So because they asked you to find dy by dx. At that time, what you do? Dy by dx is equal to 2. Why? Because you are differentiating with respect to x. So we are not getting any kind of dx, any kind of with respect to dx term. Okay. But here we are differentiating with respect to time, the other variable. With respect to time, you are differentiating height. Okay. That's why you are getting h if you differentiate dh by dt. You observe this one. Don't do this kind of silly mistake. Okay. Yes. Come on. Observe now. So do h by 2h into dh by dt. Very good. So this dh by dt, what do we want? ds by dt at h is equal to 4, right? Because our question is, they asked the condition that depth of the water tank is at 4 meters. Okay. So I want dh by dt at h is equal to 4. Okay. At h is equal to 4. We have already calculated that dh by dt at h is equal to 4 as 2 by 3 pi meter per hour. Can I substitute that? Yes, very good. Let me substitute that 2 by 3 pi. Okay. 2 by 3 pi, I am substituting there. Okay. Let me substitute now. Let me check. Is it 2 by 3 pi only? Let me check once again. 2 by 3 pi meter per hour. Yes. Okay. 2 by 3 pi. So dH by dt at h is equal to 4 is going to be, so ds by dt is equal to, what do we get? Tell me. 5 into 15 by 16 times 2 pi by 3. Okay, 2 pi by 3. Yes, 2 pi by 3. What do we get now? So you observe now. So 3 one time. So into dH by dt, no? So 2 by 3 pi means 3 by 2 pi, no? 3 pi by 2. Okay. 2 pi by 3. 2 pi by 3. Okay. So 2 by 3 pi. Sorry. 2 by 3 pi, no? That one, what I am writing. 2 pi by 3. Not 2 pi by 2 by 3 pi. Okay. 2 by 3 pi. So pi cancel here. And 3 one time, 3 pi times. Okay. And then you observe here. So here we got 2 by 3 pi, 15 h square by 16, pi into 15 by 16 into 2h, 2h into dh by dt. Okay. So it is 5h by 16, no? You see ds by dt is equal to pi into 15 by 16 h square. Okay. H square is 2h into dh by dt at h is equal to 4. Okay. dh by dt at h is equal to, dh by dt at h is equal to 4 is going to be 2 by 3 pi. Okay. And here, if h is equal to 4, we have to substitute in this, no? I forgot, into 2h, right? So 2 into 2 into our h is 4. Okay? Yes. So what do we get now? H2 ds by dt is equal to 5 into 15 into 16 into 2 into h into dh by dt at h is equal to 4. So 2h, what do we get? So 2 twos are 4, 4 fours are 16. So 2 twos are 4, 4 fours are 16. All get cancelled and you are getting 5. Okay. So ds by dt is going to be, so we got, this is area, no? Now, no doubt. Curved surface area. So it is going to be meter square per hour. Okay. So this is our final answer. ds by dt at h is equal to 4. ds by dt at h is equal to 4 we calculated. This is going to be 5 meters square per hour. Okay. This is our final answer. Okay. Understood? Yes. Very good. So please like, share, and subscribe. Thank you.